Alright, time for example 3. I'm going to do myself a favor this time and include a lot of zeros in the matrix. It just makes the arithmetic easier, so I don't know, I'll just pick one again at random, but try and increase the zeros. Yeah, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 0, 1, 1, and say 1, 0, 1. Okay. So just like before, we're going to try and eliminate everything under this pivot here. So we'll multiply row 1 times negative 1, add it to row 2. That gives us 1, 0, 1, 0, 0, 1, 0, negative 1, negative 1, 1, 1, negative 1, and this row remains the same. 1, 1, 1. Okay, and so we can have a 1 in this pivot. I'll just multiply row 2 by negative 1, so that becomes a 1, that becomes a 1, that becomes a negative 1, that becomes a negative 1, and that becomes a 1. Okay, now we want to eliminate everything above and below this pivot, so that's just this value here, so we'll multiply row 2 by negative 1 and add it to row 3. Row 1 will remain the same. 0, 1, 0, 0, 1. Row 2 will remain the same. 0, 1, 1, negative 1, negative 1, 1. And row 3 will have 0, negative 1, so that's 0 again. Negative 1 plus 1 is 0. That'll become a 2. Negative 1 times negative 1 is 1, plus 1 is 2, and again a 2, and those two will cancel to be a 0. Okay, let's see, the next step, we'll divide row 3 by 2 in order to get a 1 in this pivot position. So row 1 will remain the same, 0, 0, 1. Row 2 will remain the same, 0, 1, 1, negative 1, negative 1, 1. And row 3 will have a 1 there, 2 divided by 2 is 1, and 0 divided by 2 is 0. Alright, we're almost done. We just want to get rid of, looks like this pivot, or this value above this pivot. So we'll just add row 3 to row 2 to get, row 1 will remain the same again, 0, 1, 0, 0, 0, 1, 0, 1, 1. Because these are all zeros, so when we add them, these three values remain the same. So 1 plus negative 1 is 0, 1 plus negative 1 is 0, and 0 plus 1 is 1, and row 3 is the same. Alright, so now we're in reduced row echelon form. Let's label the columns with variables x1, x2, x3, x4, x5. We can see by looking at the columns that don't have pivots, that's this column and this column, that x3 and x5 are free variables. So let's call x3 the parameter m1, and let's call x5 the parameter m2. Then we can write x1 is equal to 1, and then we subtract everything on the left side, so 1 minus 1 x3, but x3 is m1, so 1 minus m1. x2 is equal to also 1 minus m1, and x4 is our other non-free variable. x4 is just equal to 0 minus an x5, but x5 is m2, so it's just negative m2. And now we can use these to write a vector form for our solutions, for our solution set. Actually, we have infinitely many solutions in this situation. Alright, so the idea is to isolate the free parameters and write these terms as a linear combination of vectors of these free parameters. I'll show you what I mean. So x1 always contains a 1, so does x2, and there's no other constants in these expressions. so that's our first plus. Now we isolate the m1 component. So every x1 contains minus 1 m1, see? And so does every x2 contains minus 1 m1. And of course x3 always contains 1 m1. And the rest are zeros because they don't involve m1 at all. And we do the same thing for m2. X1 doesn't contain any m2s, neither does x2, neither does x3. x4 contains a negative 1 m2, and x5 is m2. So this expression here defines the solution set for this system. Alright, thanks.